Howdy and good day, fellers. We are here with a brand new book to Algebra, a brand new unit, Unit 4, in a brand new year, 2021, and brand new opportunities for glory. I can sense your excitement. Before we start, though, I've got a couple of administrative items just to cover quickly. Just like when I was out with the whole COVID thing, as I record these, there are going to be Google quizzes posted in Google Classroom. So please, when you're done watching the video, hop on over there. I know you've got only about a half hour for classes. I'm really going to do my best to not go on tangents, not babble, and be done with videos in about 20 minutes. So you've got some time to at least get a good start on the Google quiz before your next class. You do need to get 100% on each of those in order to get credits, just like before. Math packet number 6 was posted today. If you want to get a jump on that this week because you're bored, feel free, print it out or read through it or whatever. You will get a paper copy of it when you come back on January 11th. And I will be posting a Get You Started video later this week. There is no Khan Academy due this Thursday. I'm going to assign your next Khan Academy on Thursday. What is that? The 7th, January 7th, to be due January 14th. So no Khan due this Thursday, but it will be assigned on Thursday, due next week. And grades for Unit 3 have been posted on Educate. So if you would like to take a look at those and start to work through any practice work that you need to take care of for retakes. Hopefully you have not disposed of your first book yet because the practice work for Unit 3 is in there. And so don't email me practice work. I'm not going to email retakes out like we did at the end of the try. We'll have a retake day next week for you to work on them. And I'm also going to lighten my after school schedule with geometry so that I can be more available for folks to stay after school and get extra help, do retakes or whatever. So check Educate for grades on Unit 3. And I believe that is it. All right, Book 2, let's go. You will get your book when you come back, your new, brand new, tip-top shape binder on Monday. But I did give you the sheets that you would need for this week before break. They're also posted in Google Classroom or today's pages, along with the Google quiz, just in case you misplaced them or something happened or whatever. But let's take a look at what we got coming up in Unit 4 anyway. Unit 4 is more graphing related things. We're going to talk about today something called direct variation. We get to learn about a new form of an equation. We have standard form. We have slope-intercept form. We're also going to learn about something called point-slope form. We also move to graphing inequalities on the coordinate plane. So it's not just going to be one variable like x is less than 3. It's going to be two variables like x plus y is less than 3. Okay, so we're going to move to the coordinate plane with inequalities. And then we're going to talk about parallel and perpendicular lines in 33 and 34. Only one PO other than your review ones here. PO 34, writing the equation of a specific parallel or perpendicular line. That's going to tie directly with PO 26. So if PO 26 was an objective you did not pass in Unit 3, I highly recommend getting on that practice work sooner rather than later so you can get those concepts because you will be applying them in PO 34. So that's what is coming up. But we're going to start with CO28, talking about something called direct variation. And our goal today is simply to determine if an equation is a direct variation or not, okay? And in CO21, we discussed that a relation with slope is a linear function, but there's a special type of linear function which is called direct variation, right? So kind of what's going on here, where's a good place to draw this diagram? I'll draw it down here in the corner and I'll erase it when I'm finished. But so basically, right, we have functions, okay, which are any relation where there's exactly one y value for every x. Within functions, kind of a subset of it, we have linear functions, which we talked about in unit 3, and linear functions are specific functions that are a straight line. There's a special type, right? Functions that are not linear might be like this or like this, right? They are functions, but they're not linear. They're not straight lines. And then within linear functions, even further down, more specific, we have direct variation, which I'll abbreviate dv. Okay, so we're getting into kind of like a special type of equation here, a special type of graph within the function and linear function set. So direct variation is, we'll say when y is proportional to x. Okay, where y is proportional to x. So we're talking about ordered pairs here, right? We're talking about slope and intercept form, linear functions. That's why we're using x and y. But we also have this word proportional. Okay, when y is proportional to x, it is a direct variation, which means that y is always half of x, or y is always 3 times x. Y being half of x would be represented by this equation here. Y equals half of x, whatever x is, y will always be half of it. Or let's say that y is 3 times x. That would be the equation y equals 3x. Whatever x is, we always multiply by 3 to get y. There's a proportion there. So essentially, if you're looking at these equations, maybe you've noticed here, what's kind of missing? Y equals 1/2 x, y equals 3x. What's missing there? Well, it's not that it's so much missing this constant at the end of it, right? We're used to seeing equations in y equals mx plus b, the slope times x and then the y-intercept. Well, in this case, there's no y-intercept written, which means that, it's not that there is no y-intercept, but it means that the y-intercept is 0, or the graph's going to pass through the origin. Basically, to determine direct variation in a graph, the line is going to pass through the origin, which of course is 0.00. Or in an equation, there's no y-intercept, which means it's 0, right? It passes through the origin. There's no y-intercept written. Doesn't mean there isn't one, technically. It just means that it passes through the origin, passes through 0. It's that constant at the end, it's that y-intercept other than 0 that makes x and y disproportional or unproportional. It's not a direct variation. For example, if we have the equation, well, let's just kind of look down here actually. Okay, let's go to Mr. Heavy Pencil section. We have that equation y equals 4x plus 2. Are x and y going to be proportional? Well, let's make a function table. If x is 1, okay, I'm going to plug in 1 for x. So 4 times 1 is 4, plus 2 is 6. Okay. If x is 2, 4 times 2 is 8, plus 2 is 10. If x is 3, 4 times 3 is 12, plus 2 is 14, right? There's not a proportional relationship between x and y. Is y equals 4x plus 2 a function? Yes. Is it a linear function? Yes, it does have a slope. But is it direct variation? No. And the reason why is because if we look at the proportional relationship between x and y here, does 6/1 equal 10 over 2 equal 14 over 3? No, they're not proportional. And it's because of that plus 2 there, right? It's because it has a y-intercept other than 0. Okay, anytime an equation or a graph has a y-intercept other than 0, it is not going to be direct variation. Easy way to tell. All right, easy way to tell. So let's look at I'm going to erase this here so we can have more space to look at the other three. In the directions, it says to write the relation in slope-intercept form, determine if the relation is a direct variation. We're going to talk about some other ways to do that so you don't have to write it necessarily in slope-intercept form. But then it also talks about the constant of variation, which is a really fancy schmancy way just to say slope. Okay, so if it is direct variation, I want to know what the slope is. Kind of what is that scale factor to get from x to y? In the two examples we did earlier, you know, when y is half of x, that's the scale factor, right? Whatever x is, y is going to be half of it. Here, the constant of variation is 3. That's the scale factor. Whatever x is, y is 3 times that. Okay? All right. I don't know how long I've been recording. Sorry, I forgot to look at the time when I first started. So hopefully my internal clock will end us at 20 minutes or close to it. But here we go. First one, give it a graph. Is this direct variation or not? Well, in our examples, in our definitions up above, we said for a graph, does it pass through the origin? Does it pass through 0, 0? Yes, it does. So is it direct variation? Yes, it is. Okay. And then as far as what the constant of variation is, again, we don't have to write it in slope-intercept form here because we have the graph. If we're looking for the constant of variation, remember that just means we're looking for slope. So what is the slope of this line? Well, let's see. Where does it cross through another corner here? Here it does. What's the slope? This kind of goes back to CO, was it 21 maybe even? Finding the slope given a graph. The constant of variation, which I will further, or going forward, I will abbreviate CV because this is a lot to write here, up 1 over 3, right? So whatever x is, y is a third of that. Let's just test this quickly here, okay? We have an xy table. We have ordered pairs 0, 0. That's the origin. This ordered pair, the second one that I marked there is 3, 1. Okay. We have an ordered pair down here, which is -3, -1. Basically, you know, y is always a third of what x is. 1 is a third of 3. -1 is a third of -3. If we compare these two relationships here, are they proportional? Yeah, they're the same. 1/3 and 1/3. We don't want to test 0, 0 because obviously you can't divide by 0 there, but they are proportional, right? And the reason why is because there's no y-intercept. It passes at 0. Okay, passes through the origin. We already talked about that one. Looking at an xy table here. What do you think? Well, if we look at the relationship between x and y, 4/3, 12/9, 16/12, 28/21. Are all of those equal? 4/3 equals 12/9 equals 16/12 equals 28/21. Yeah, if you simplify each of these other ones, you get 4 over 3, don't you? Okay, that means that there is a proportional relationship or a direct relationship between x and y. Okay, so is this direct variation? Yes. We found that proportional relationship by noticing that y divided by x right? We'll even write it up here. Y divided by x, it's the same for all of them. Furthermore, here's the really nifty thing here. That constant of variation, guess what it is? Well, it's 4/3, right? That's the fraction that they all simplify down to be. That's going to be your slope. That's going to be your constant of variation. If we were to write this in slope-intercept form, our equation would be y equals 4/3 x. Okay. Next one, 2x plus 7y equals 0. Being an equation, we are going to write this in slope-intercept form. We didn't do it here because it was already written there for us. But 2x plus 7y equals 0. Hopefully you recognize this as being in standard form. X and y on the same side here. So to get to slope-intercept form, we're going to subtract 2x from both sides. So y equals negative 2x plus 0. Divide everything by 7. 7y divided by 7 is just y. Negative 2 divided by 7 is negative 2/7. And 0 divided by 7, well, that's still just 0. What do we have? Direct variation? Yay or nay? Take a look at that y-intercept. That's the key here. A y-intercept plus 0. Yep. We've got direct variation. Why? Because this line is going to pass through the origin because the y-intercept is 0. And what's that constant of variation going to be? What's the slope? Negative 2/7. Okay? The slope of that line. So you've got a graph, which you just have to look at it, right? Does it pass through the origin or not? And then calculate the slope. For an equation, put it in a slope-intercept form. And if you look at the 4 equations down at the bottom here, you'll see that they're in all sorts of different forms. You've got the last one, which is in standard form. The first 3 are just kind of, any old form, nothing specific, but you just need to get y by itself there. And then the second row, you got 2 graphs and 2 tables. And with that table, you want to look for what is the relationship of y divided by x. Is y divided by x the same for all of them? And if it is, then yes, it's direct variation. And whatever that simplest form fraction is, and the example that we did here was 4/3 for all of them, right? That's going to be your constant of variation as well. Okay? So, I believe I didn't mean to I just captured this. I can look back fondly on it in years to come if I forget what I did. Oh, now what's it doing? Oh boy, if this video is longer than 20 minutes, I blame this. No, I don't want to see the changes. We're going to clear the ink. There we go. So you've got 2 rows to do here. You do have the Google quiz as well. It'll talk about maybe some definitions of what we wrote up at the top of the page. It'll have some of these homework questions on there. I think you're probably going to spend the most time on the equation row here because it's not quite as cut and dry as the other ones, right? For the graph, look at it. For the tables, just compare y divided by x. For these, being in all different forms, there's going to be different techniques to get it in a slope-intercept form, but essentially, you want to get it in y equals mx plus b, right? Get that y variable isolated, that y variable by itself on that left side, okay? I do have office hours today from 1:30 to 2. Of course, my email is always open, so if you just got a quick question for me, please shoot me an email. I'll respond to you as quickly as I'm able to. If you do want to Zoom, I will post a Zoom link for anybody to join in from 1:30 to 2 o'clock. And then so they'll be posted in Google Classroom. Just click on it, jump in. Wherever you end up, you're in line. I'll just run through as many questions as I can from anybody. So there's one you get stuck on, whether it's on the quiz or on the homework here, please either email or Zoom with me 1:30 today. So that is CO28. That is how you math. Do not forget to like and subscribe. Happy New Year to all. Have a great day. and I'll talk to you later. Bye.